So, grade 11s. Now, a number of you were asking me about the lab and in terms of error bars, and I showed a few of you how to do that during today's lunch. However, some of you really want me to see me doing this, so I made this video and screencast. Now, going back to the lab, and this is from Ms. G herself. Now, this is the part where the focus of the lab is to propagate uncertainty and make that into error bars. So in this case, we will need to propagate uncertainty in this case. Now, just like those of you who I saw today, now I just made up this set of data. The volume of water, it should be in slash centimeter cube. So that is in centimeter cube. Having some difficulty. Slash centimeter cube. And that will have to be exponential. I'll do that a little bit later. Now this one is slash grams. Okay. Now, so in this case, when we make the graph, I'm just going to make up some numbers. 153.1, 155.5, 155.5. Let's just say 56.9. That's very interesting data I have here. 1.58.4. 1.58, no, 1.568. And just add a few more things. 161.2. Okay, let's just say that. Okay. Now, obviously, this will be your x-axis because that's your independent variable. This is your y-axis. Now, to some of you, now because this is your x-axis, this set of data, the volume of water, you don't really need to propagate any variable, any errors, because now, assuming you did all this only in one trial. So in this case, what you do is this, because when you think back in your experiment, you get your grad cylinder, you pour water in it until this volume, and then you stop. So this here, the number you get here, the only uncertainty is from the absolute value of the grad cylinder. So in this case, I'm going to make a column here. Or just say here, grad cylinder, for using 100 mil grad cylinder, your smallest increment is 1 mil, so which means it's plus or minus 0.5. So I'm going to add here, insert symbol. No, I'm not done, but I can just pause it. Let me enter at least this one symbol thing. Where the heck is the plus or minus thing? Plus or minus symbol cell. Code. That's not what I want. where's the math? Plus. Oh, there you go. And 0.5 centimeter cube. I'm just going to pause here for a moment. Okay, so where was I? So that's a absolute uncertainty from the grad cylinder. Okay. Now in this case, in terms of the absolute uncertainty of your scale, of just your scale. Now keep in mind a couple of things. This is x-axis, that's y-axis. So x-axis, since all these measurements are you only get these numbers purely from the grad cylinder, so you don't need to propagate anything. These numbers and its uncertainty, it's only depend on this grad cylinder. However, when you're looking at this mass of not the scale, no, so this beaker and water, now this number is dependent upon the scale as well as the volume of water, because keep in mind, you get this number from measuring the water of the grad cylinder. So an error could have happened here, or an uncertainty happened here, plus you pour this onto a beaker on top of the scale. And so in this case, you also have another layer of uncertainty. So in this case, you have, for this here, for the y-axis, you have the uncertainty from the grad cylinder and the uncertainty from the scale. So now, because these two are not the same unit, you will need to propagate those units. Okay. Now, if you want to look, if you look back under blah blah, under September 24th, the lesson on quantifying and propagating uncertainty. So station 5 here. Now, when you have uncertainty that are both two different sets of units, you will have to propagate them. Okay. So in this case, you have now if you look back at this, you have to convert the absolute uncertainty to percentage, add them together, and then convert the total uncertainty back to absolute uncertainty. So in this case, your percent, so let's use this column of percentage uncertainty from graduated cylinder. Okay, so in this case, I'm just going to use this set of data, this third row data. So here, if you look back at this note, percentage calculation, how do you find percentage calculation is by going here. So percentage is absolute divided by measurement times 100. So on Excel, what you do is, now, absolute uncertainty of the graduated cylinder is 0.5. So 0.5 divided by the measurement. So in this case, minus 92. Now, you're supposed to times 100 to make a percentage, but since you're on Excel, you can just say, oh, this is a percentage, like this. And I should just give a few more decimal points. So that's an uncertainty from the graduated cylinder. Doing work. Percentage uncertainty from scale. Now, so in this case, same idea here. Now, your digital scale that we use have 2 decimal places, so it means absolute uncertainty is 0.01. So in this case, 0.01 divided by the measurement again, which is this, which gives me this number. And again, I convert it to percentage and give it a few more decimal places, right? Now, if you look back at the propagating uncertainty one, so in this case, you have to add them together, okay? Now, again, the reason why you add them together is because this number could have been influenced by the uncertainty of the grad cylinder as well as the uncertainty of the scale. So you have to consider both of them together. So in this case, you sum of percentages. So it's just really this plus this gives you that. Now afterwards, you have to convert the total uncertainty back to an absolute uncertainty, right? So in this case, now because this uncertainty here will be the uncertainty for your y-axis. So in this case, this is in grams, you have to have it into grams. So uncertainty in grams. I think I spelled it right. So if you have, you know that the microphone picks up your voice, right? Watch it somewhere else. Anyways, absolute uncertainty divided by measurement gives you this. So in this case, to find the absolute uncertainty, what you need to do is percentage time measurement. So where am I? So measurement times a percentage. So in this case, this times this. So that will be the uncertainty of this measurement, okay? Now, as you can see, we don't need that many decimal places. Now, as you can see, a few things. First of all, we did this, and this is absolute uncertainty of just this set of numbers. You'll have to do this pretty much the same thing for all this, and then hence you'll get a whole bunch of numbers. Now, because it is Excel, I can just do this little magic, which means corner drag, because when I do that, it will be these numbers of corresponding this column. Same thing here. So the sum are also, as you see, all these sum of percentages are different. So these will all be different. Now, make sure when you are making a graph, insert. Where's the scatter plot thing? Right. Scatter plot. All right, so scatter plot is here. Always maximize the size of the graph. And you need to add error bars. Now you have to do custom error bars as shown. Format data plot. Select data. Nope. No. have to look for. Add data element, error bars, right. It's none of these. You have to use the custom. You absolutely do not need horizontal error bars, because you don't need horizontal error bars simply because this here is the volume, which, as we said before, that is the only error bar. Okay, so you only need up and down ones. So the error bars, click on that. Now my camera screen is blocking the view. So the line error bars. So annoying. Anyways. Add element, error bars, options. All right, custom. So you have the custom, go to specify values. So both plus as well as minus will have to be coming from this column. Press OK. And oh, look. Let's make this back a little bit bigger and more centers. So now all these are relatively close. So in this case, it doesn't look very obvious. But imagine if, or doesn't imagine, if I actually change this value to a 2.5, something significantly bigger, look at that error bar. So much different from the others. So let's go back. So here, all these error bars are roughly the same size based on the scale. So, and was it add trend line? Now, I'm not going to talk about trend line. It seems like based on a lot of you know how to do that already. Also, make sure your axes are correct. This is not a correct title. Please don't just copy and paste on this. But this is basically how you propagate uncertainty so that your uncertainty, your error bar, you can propagate the uncertainty so that you can use that as an error bar for your y-axis. Okay, summarizing it, because this is mass of the beaker and water is dependent upon the uncertainty from the grad cylinder as well as the uncertainty from the scale. You have to consider both and propagate the uncertainty. And this is how you do it on Excel. Okay? There's probably other ways to do it, but this is how I did it. Okay? There you go. Have a good night.